You ever really stop and think about it? The incredible challenge of punching a hole thousands of feet, sometimes miles, straight down into the earth. We're talking through layers and layers of solid rock. I mean, it sounds basically impossible, right? But for over a century, one amazing piece of engineering has made it almost routine.
So, how do we do it? How do we take on geology itself and win? Well, the answer isn't just about using brute force. It's a total masterpiece of mechanical design that has, quite literally, been powering our world for a very, very long time.
All right, let's get into it. Say hello to the tricone bit. Now, at a glance, it might just look like a heavy, kind of complicated chunk of metal. But this is an absolute engineering marvel. It's designed to do one thing, and do it with brutal, beautiful efficiency: shatter solid rock.
So here's our game plan for this explainer. First, we'll talk about its role as the ultimate drilling workhorse. Then, we're going to dissect it. Look at the anatomy of this beast. After that, we'll uncover its rock-breaking secrets, see how it cleans up its own mess, and finally, we'll see how all these pieces work together in perfect harmony.
First up, the drilling workhorse. Look, whether we're talking about oil and gas, geothermal energy, or even just water wells and mining, the tricone bit is the absolute go-to tool. It's what you use to get through the toughest layers of the Earth's crust. It's really the unsung hero, working hard deep beneath our feet.
All right, let's pop the hood and get into the anatomy of the beast. To really get how this thing works, you've got to see what it's made of. And as the name kind of gives away, the whole design is built around 3 super rugged cones. Each one is free to rotate on its own set of bearings. And on those cones, that's where you find the teeth.
And you know, not all tricone bits are created equal. They basically come in 2 main flavors, which you can see right here. On the left, you've got the milled-tooth bits. The teeth on these are literally carved right out of the steel cone itself. They're perfect for chewing through softer stuff, like shale or clay. But for the really hard, abrasive rock like granite, you got to bring in the heavy hitters on the right, the TCI bits. These have ridiculously hard tungsten carbide inserts pressed right into the cone.
But the real genius here, the secret sauce, it isn't just about the teeth. It's this subtle little design feature called offset. See how the cones aren't perfectly straight? They're angled just a tiny bit. This small misalignment is so important because it stops them from just rolling smoothly. Instead, it forces them to actually skid and gouge at the rock. And as you're about to see, that makes all the difference in the world.
So that brings us right to section 3, how it breaks rock. And man, this is where the magic really happens. The tricone bit uses this devastating 1-2 punch, combining just immense force with some really clever motion to completely obliterate rock formations.
Let's break this down. So the first method is just pure, unadulterated brute force, crushing and compression. Imagine the entire weight of the drill string, we're talking thousands and thousands of pounds, all focused onto the tiny, tiny points of those teeth. That creates an insane amount of pressure that just overwhelms the rock's compressive strength, causing it to literally crumble. But that's only half the story. That's just the opening jab. The second method is chipping and shearing, and this is where that offset we just talked about comes into play. As the cones skid sideways, they create a shearing force. It's like they're attacking the rock from the side. And here's the thing about rock. It's way, way weaker when you try to pull it apart than when you squeeze it. So this shearing action just chips off much bigger pieces. It's a brilliant combo of raw power and clever finesse.
So let's watch this cycle in action. First, a tooth slams into the rock face. All that weight from above is focused on that one tiny point to compress the rock right underneath it. This creates tiny fractures and basically pulverizes the material.
Then, almost at the exact same time, that skidding motion from the offset kicks in. It creates that shearing force, which takes advantage of those initial fractures to chip away larger flakes of rock from around the edges of that crushed zone. And just like that, with that little piece of rock totally destroyed, the cone continues its journey. It begins to roll forward, bringing a whole new set of teeth into position, ready for the next impact on a fresh patch of rock at the bottom of the hole.
And finally, you guessed it, repeat. This cycle of compress, chip, and roll happens continuously, thousands and thousands of times a minute. All 3 cones work together, making sure that the entire bottom of the hole is systematically destroyed with every single turn of the drill string.
Okay, so we've gotten really good at breaking rock. Awesome. But that creates a brand new problem, which brings us to our next section.
cleaning up the mess. Think about it, if you just leave all that crushed up rock at the bottom, the drill bit would just spin around uselessly. It would be grinding up old debris instead of cutting new rock.
Exactly. What in the world do you do with all that debris when you're thousands of feet underground? It's not like you can just send a Roomba down there. You need a system that can clear the path for the bit, and it has to do it in real time. Well, the solution is just as brilliant as the bit itself: high-velocity drilling fluid. In the industry, everyone just calls it mud. And this isn't the stuff you find in a puddle. It's a carefully engineered fluid. It gets pumped at super high pressure all the way down the inside of the drill pipe, through the bit, and out of these specialized nozzles aimed right at the rock face. This mud is the bit's essential partner. It's a multitasking superstar, performing 3 critical jobs all at once. First, powerful jets of mud blast the teeth clean and lift all those rock cuttings out of the way. Second, it cools the bit, because trust me, it gets incredibly hot from all that friction. And third, the circulating fluid carries all those cuttings up the space between the drill pipe and the wall of the hole, all the way back to the surface, while also helping keep the hole from collapsing.
And that brings us to our final section, where we really see how this whole thing comes together: engineering in harmony. Because you see, the tricone bit isn't just a tool, it's really the heart of a very complex system, where mechanics, advanced materials, and fluid dynamics all have to work in perfect concert.
You know, the source material puts it perfectly. It says, the tricone bit and the mud system are inseparable partners in efficient drilling. And that's just it. One simply cannot work effectively without the other. The bit breaks the rock, and the mud clears the path so it can do it again.
So, in the end, that's what we have: a finely tuned, incredibly powerful mechanism. It combines the brute force of compression, the clever finesse of a shearing action, and the absolutely critical support of a high-pressure hydraulic system. All of it working together to conquer solid rock deep beneath the surface of the Earth. And it just makes you think, doesn't it? This incredible device is just one example. What other hidden engineering marvels are out there, quietly and brilliantly powering our modern world, just waiting for us to notice them?